to say analyzing graphs. Analyze graphs. Or analyze functions, sorry. Yes. No, spirit rally, but it's not at the flagpole, it's at the triangle. I found that at 4th grade. Don't look at me like I'm crazy. I'm not in charge. I didn't make that decision. I asked the 4th period, that's why I know. Because now I get to send a reminder out to my lovely children. Because that means Linkert has to go. All right, ready? As long as this ever will load. Today's 10-11. I said analyze, oops, Y, Z, E. The Y and the Z kind of got smushed together. Analyze functions. You're also going to deal with graphs. Now, I'm not going to actually analyze in my notes. Do you understand? My notes are going to be more of what does each function have, what does each function consist of, all right? Can we find positive and negative? Can we find increase, decrease? Can we talk about domain and range? Okay? And that kind of thing. Because what's going to happen is in your homework tonight, they're going to give you a graph. And you're going to have to take that graph, know what type of function it is. There's 4. And then you're going to have to decide, does it have a vertex? Does it have a interval of increase and decrease? What is its domain? What is its range? Is it positive? Is it negative? Do you understand? So there's lots of pieces that go with it, but you need to know what each one has. So I'm going to write the essential question and the topic, and then I'm actually going to turn my paper sideways. Also, a little heads up on your test. Notice that all of this right here really goes with this one also. So if you can factor and solve, you should be able to do all of these also, right? You should know how to get to intercept form. You should know how to get to by completing the square. So those go together. Characteristics of graphs. All of these go together. This is not on the test, and neither is this, but exponential is. Got it? Okay. Oh yeah, I took 3 pages yesterday, huh? Thanks. So how do I classify functions? Based on their graphs? Then I'm actually going to do my notes sideways. So I'm going to make it look like this. Understood? So once you're done writing, I'm going to turn my paper. So if you want to make yourself 4 columns the other way, you can. Ready? All right, 4 columns. Here we go. Except for when you have your phone out underneath your desk. Yeah, thanks, Jonathan. Ever and ever and ever.
I'm sorry, what?
I said I haven't seen you in forever.
I know. I haven't talked to you. I meant to call you this weekend.
All right, we're going to label across quadratic, absolute value, exponential, and linear. All right, let's write the functions for a quadratic. I'm going to start you off with f of x equals. What is one of the quadratic functions we have? How many types of quadratic functions do you have? 1, 2, 3, 4, 5, how many?
You don't know?
How many types of quadratic functions do you have? 4? What are they? How about 3? What are they? Standard, intercept, and vertex. So what's the first one? Standard is what? F of x equals what? Ax squared plus bx plus c. I didn't. All right, standard form is what? Oh, not standard form. That's standard form. Then we need what? Intercept. So what's intercept? Times? You want to do vertex form? X minus h squared. What goes next? Plus k. That is vertex form.
Why don't you suspend him?
Then after that is what? You need to know this for your test. Close. Minus. Minus p, and then q is next. X minus q. Good. Close. It's got to be minus. All right, so you have standard form, vertex form, intercept form. For absolute value, how to write absolute value? F of x equals what? Oops. There's no parenthesis. Sorry. A, absolute value,
He's right.
x minus h,
Yes, I took his phone.
plus k. Exponentials what? F of x equals, there's no a here. Well, there is, but we're not doing a. B, what's the word that goes to the top? B to the x. What is it? Plus h plus k. And lastly is linear. F of x equals what? Think of IM1. How about I start you out with y equals? There we go. So f of x equals mx plus b. Got it? All right. So now, let's talk about what is the starting point for a quadratic. Where do you start? A vertex. You have a vertex here. Most of the time it's h comma k. Sometimes it's not. You can also find it negative b over what? 2a. You can also find it what? PQ or P plus Q? P plus Q divided by 2. Do you need to know all those ways? Yeah, pretty much. You can write on the worksheet. All right, so that's my quadratic. Absolute value also has a what? It also has a vertex, which is also h and k. Exponential does not have a vertex. It has a what? It does have an asymptote. We're going to talk about that in 1 second. How do we start it? It has a horizontal and vertical shift, right? But where do I start? Where did I say your parent function started at? 0, 1. So we have a starting point of 0, 1, which is from your parent function. Remember that one. What does slope linear functions have? They have slope.
They decided not for A's today. That's what slope is.
It has rise over run, which is your slope. What else does it have? The y-intercept. How do you find y-intercept? How do you get b? 0, no, you just have b, but how do you write that as an ordered pair? 0, b. 0, b. We're done with linear for now. Do you understand? I don't want to go back to linear for right now. We're going to stick on the other 3 for right now. All right, so let's talk about quadratic. Every quadratic also has a what? A y-intercept. How do you find y-intercept? Plug in 0 for x. Very good. Now I know that in standard form it's a special, right? I can find it super easy. It's just what letter? It's just letter C. But for the other ones, I don't want to say that because it doesn't always work, right? So I'm not going to say that. But I know if I plug in 0, then I know for standard form it's just letter C. Then we have absolute value. Absolute value, how do you find that? Could we find it? Yeah. Did I make you? No, it was nice. But if I needed you to, how would you do it? You still plug in 0 for what? And for x. Good. Exponential. Does it have a y-intercept? It does. But do I really care about it? No. Especially if there's a horizontal shift. If there's no horizontal shift, it's that starting point whichever way I move up or down. But because I have a horizontal shift, I'm not worried about it. Okay? So I'm not going to worry about that one. But what does an exponential have that the other ones don't? Oh, you're my hero. Thank you. What does it have? There are about 27 of you in here. What does an exponential function have? Asymptote. You act like you've never heard that word before. Has an asymptote. How do you find the asymptote? Darling, what is wrong? It's just K. I feel like you did not learn this well enough last year. I think you're missing some pieces. All right, so you have an asymptote of K equals a number. Okay. All right. What else does a quadratic have? Oops, don't ask how that happened. What does it have that's special? What? It could have x-intercepts. Does it have to have x-intercepts? No. So I don't want to write that. We're not at range yet. One of you is going to move. Jonathan. Your new seat's here. In front of Christian. Can't handle it. What else does it have? Sorry. Axis of symmetry. Why do I care about it? Not because it's the axis of symmetry. That's not a good answer. Why do I care about the axis of symmetry? It's where I can now flip it, right? I have a mirror. If I'm using this as my vertex, what's my axis of symmetry? X equals h. Good. In other words, it's part of the what? It's part of the vertex. Okay? They're so loud. Absolute value. It has an axis of symmetry, right? Yeah. Because when I graph it, it looks exactly like the parabola, except for it's now a V. I still cut it in the middle. Remember, we still graph whatever here and whatever here. So, what does the absolute value have that's also special? How do I find the other points? So let's write that down. We find other points by plugging in an x value. Where? How do you get that x value? Of what? We either go to the right or to the left of the vertex. Yes? Exponential. We didn't finish exponential. We're almost done with exponential. What does it have? How do you graph it? I know the starting point is 0, 1, but then how do I actually graph it? 0, 1 is just the spot I start at. What does h tell us? Left to right. So that's horizontal what? Good. Horizontal shift. K tells us what? Very good. H is always opposite and K is always the same. Okay? What do quadratic and absolute value have? They both have something special. Linear doesn't have it, neither does exponential. They both have vertex, which means they both have a what? Where you said that? Min or max? Linear and exponential do not have a min or a max because they have no turning point. All right, let's think about this. What else do they have? Do they have increase and decrease? How do I find increase and decrease on a quadratic? What is it based on? It's based on the vertex. Because that's your turning point, right? What about for an absolute value? Oh, it's still based on the vertex. Does an exponential have increase and decrease, or does it have one or the other? Why is it only one or the other? Exponential. Why is it only one or the other? You're either growth or you're decay. If I'm growth, then am I increasing or decreasing? I'm increasing. If I'm decay, I'm decreasing. So it's increase or decrease, not both. Based on the B, which is your base, because it's either growth or decay. Is a linear function, we're going back to linear now, is it increase, decrease, or both? It's only increase or decrease. Why? What's that one based on? Very good, based on slope. Okay, what else? Domain and range is the last one we're going to do, but right before domain and range, what do you usually tell me? Narrow and wide. Absolute value and quadratics have narrow and wide. Does a linear have a narrow and wide? No. Does an exponential have narrow and wide? Nope. What other intervals am I missing? I have increase, decrease. Positive or negative. Can absolute value have positive and negative? Yep. Can an exponential have positive, negative? Yes. Can it also just be one or the other? Yes. Same with quadratic, that too works. And in linear, positive, negative? This one's always going to have positive and negative, unless we have vertical or horizontal. But we usually don't have horizontal lines, right? It's usually going to have both. Most lines will have both, right? So one of the only ones that would probably have both no matter what. Because the quadratic and exponential, depending on where they're at, your vertexes will determine if you have positive and negative or just one or the other. And lastly, domain and range. Domain for a quadratic is what? Negative infinity to positive infinity. Domain for an absolute value is the same thing. Domain for an exponential is the same thing. Domain for a linear is the same thing. Oh, look at that. Not till we get to IM2 will it change. Alright, for domain for, or not domain, range for a linear function, I'm going to work backwards now. Range is what? What's range on a linear function? It's going like this. There we go. It's negative infinity to positive infinity. Is that ever going to change? Probably not, unless you have a horizontal line. But we're not worried about horizontal lines. Okay, let's go backwards. Exponential. Your range is based on what? Very good. So very good. It doesn't help I have a cough drop in my mouth. And then on absolute value, your range is based on what? Oh, yes, but what is that? Okay, of the vertex, which is y value in case someone gets confused, right? And what is it based on a quadratic? Same thing. Oh, I put on twice. Okay. Should you know all these things? Mm-hmm. I'm done. So what I just did for you, in a very easy kind of way, is I have now condensed everything about functions kind of on one page. A little bit.